In this video, we're going to be looking at how to solve systems of linear equations very simply using NumPy. To start with, we're going to go ahead and import NumPy as MP. And then let's take a look at these two equations. So we have equation 1 with 3 times x naught plus x1 equals 9, and equation 2 where x naught plus 2 times x1 equals 8. So this is a simple system of linear equations, but this can be extended out as large as you need. And we're simply going to use NumPy's linear algebra capabilities to solve for the appropriate solutions for x naught and x1. Okay, so how do we do this? Well, first, we're going to make an array that represents all of the coefficients for our variables. So we'll say a equals mp.array, and here we'll have 3, the coefficient in front of x naught, and 1, the coefficient in front of x1. So that's going to be representative of our first equation. And we'll make a second list with the coefficients that represent our second equation in here. So here we can put 1, since that's the coefficient in front of x naught, and we can put 2 in here. Great. Now the next step is to then keep track of these constant values, and I'll put that in an array named b. And equation 1 is equal to 9, and equation 2 is equal to 8. And so we're done there. And then the final step is to say, let's call our solutions x. We'll say mp.linalg, grabbing the linear algebra capabilities of NumPy, and we'll do .solve, and we'll give it our coefficients a and the values b. And as simple as that, we can go ahead and print. We'll say x naught, comma x1 is equal to x. Let's go ahead and run this. So we'll import NumPy. We're going to define a. We'll define b. So here's a. Here's b. We'll do linear algebra solve a comma b. Now here are the x values that satisfy this linear relationship. We can go ahead and print x0, x1 is equal to 2, 3. So simple as that. We have solved a system of linear equations, and no matter how many equations you're dealing with and how many variables, as long as the system is well defined, you'll be able to find a solution very simply. And we can check to make sure we've done okay. We can do all close to check that all of these variables are close, and we can do dot and x and compare that to the value b. So we're going to dot x times a and see if this gets us the right solution. And sure enough, there we have it. We've solved a system of linear equations in just a few lines of code very quickly and with no algebra on our part. So good luck.